The current default posture for AI safety relies heavily on observability layers. Engineers deploy LLM monitors and probabilistic alerting systems over agentic frameworks. The mechanical flaw in this architecture is timing. Probabilistic scoring systems are inherently post-hoc. They trigger their alerts only after a state mutation has already been initiated in the database. Relying on latency-driven mitigation accepts a critical vulnerability. It assumes an unauthorized action will physically execute before any intervention can occur. That latency is systemic risk. On the left side, post-hoc monitoring results in chaotic error states and leaky data streams, reacting after damage is done. Compare that to the right. Runtime governance acts as a physical choke point. If there is ambiguity, the system triggers an immediate execution halt. Governance evaluated after execution is merely telemetry, and telemetry is not enforcement. The engineering objective is to architect a system where governance exists as a deterministic constraint. This constraint must be evaluated strictly before any state mutation is allowed to happen. Accepting post-hoc observability as governance means accepting systemic risk. True security requires moving away from probabilistic advice and building a non-bypassable pre-execution boundary. Building this control plane begins with a bedrock architectural axiom. AI models and agents must be treated strictly as untrusted compute nodes. The first step of containment involves isolating these nodes within ephemeral, lane-isolated memory environments. We implement these natively as distinct namespaces or micro-VMs. A micro-VM is a lightweight virtual machine designed to provide hardware-level security isolation with minimal performance overhead. In this architecture, the intelligence layer determines its intended actions, but the control plane dictates what is physically possible to execute. This diagram maps the containment strategy. In the bottom gated execution substrate, isolated AI models are separated from external data. Notice the padlock icons. These lanes lack external network routing, DNS resolution, and direct outbound TCP primitives, the fundamental protocols for network messaging. The execution substrate entirely lacks the memory pathways required to interact directly with external databases. Identity credentials for external APIs are deliberately removed from memory, guaranteeing the boundary remains non-bypassable. By physically stripping network routing and credentials at the hardware layer, we eliminate the possibility of an agent independently bypassing the control plane. This creates a communication paradox. We must ask how an isolated agent interacts with the external world if it has zero network access. The solution requires redefining agent tools. Tools provided to the agent are actually internal RPC stubs. RPC, or Remote Procedure Call, is a protocol that allows a program to request a service from a program located on another computer or network without having to understand the network's details. When attempting a task, an agent merely passes a structured intent payload to the RPC stub. The stub then forwards that intent directly to the control plane. Look at the vertical arrows pushing up from the execution substrate. They trace the intent payload from the isolated enclave into the central control plane. With all other network pathways destroyed, this vertical path is the single egress route for intended state mutations. This juncture serves as the definitive structural boundary between the execution substrate and external API layers. Absolutely every intended action must first traverse this central control plane, where it is subjected to strict, perfectly deterministic evaluation. Lacking alternative egress routing, the pre-execution authority gate captures 100% of agent intent before a single network packet ever leaves the agent enclave. The validation engine operates under a strict mandate. It must rely purely on deterministic logic, entirely devoid of probabilistic inference or scoring. High-level human policies are compiled into low-level deterministic rules. These execute as attribute-based access control and role-based access control constraints. ABAC evaluates policies based on attributes of the user or environment, while RBAC assigns permissions based on a predefined user role. Inside the validation engine, the request payload is isolated and evaluated strictly against these loaded, compiled policy constraints held in memory. The architecture maintains a default deny posture. Any ambiguity or unmapped intent in the request translates instantly to an execution halt. This diagram breaks down a validation failure at RPC ingress. Notice the wall. representing the container boundary where unauthorized requests are blocked. The failure triggers a synchronous drop. The payload is discarded entirely in memory before external routing is established. Simultaneously, the engine freezes the agent's memory state and opens an escalation pathway, routing the frozen context back for human review. The agent cannot autonomously retry or attempt to subvert the block. The execution thread remains cryptographically locked in this frozen state until unblocked by a human protocol. Deterministic evaluation guarantees that ambiguity results in an instantaneous, absolute halt, ensuring unauthorized state transitions never reach the network boundary. A deterministic system is incomplete without immutable cryptographic proof, showing that a policy was evaluated and either permitted or blocked. We rely on two enforcement artifacts. Artifact A represents trace logs for rejection events, while Artifact B shows transactional receipts for state mutations. Let's focus on the transaction receipt. It journals the exact payload. Notice the cryptographic signatures and precise timestamp confirming the event. These records are handled by the immutable receipt service, illustrated in the bottom right. It writes receipts to an append-only ledger using Merkle trees. The receipt must be successfully stamped into the chain before the actual state mutation is finalized. If the receipt cannot be written to the ledger for any reason, the rollback condition triggers. The transaction is instantly reversed and execution halts. Absolutely no action can occur off the books. If governance is not deterministically enforced strictly before state mutation, it is not governance. It is merely hope. Through structural isolation and cryptographic proof, we transform governance from a probabilistic advisory function into a physical, deterministic law of the execution environment.